Hello students, I myself Gurmeet Singh, Assistant Professor at Abesit College of Engineering, Ghaziabad. Today my lecture is on embedded networking. The topic is the recommended standards 232, 422 and 485. These are the recommended standard, and what is the theme, what is the idea? Only to connect two devices, two embedded systems, how they are sending their data, that is the transmitter, and on other end there is the receiver, and they are communicating each other by the way they are sending. One is sending and other is receiving, or on other hand the other is sending, the first one is receiving. This means this is a full duplex, how the data is sending and receiving, and we are connecting those devices by the way of network. In today's class, we have the recommended standard. The first standard is 232, 422 and 485. This is the serial bus communication protocol. Already in previous lecture, I told that in the serial bus communication, the one bit is sending at one time and not all the bits are sending. That is in the parallel communication. In the parallel communication, all the bits are sending at one time. But in the serial bus communication, one bit is sending, then other. It means how many bits are there, how many seconds we need to send it from transmitter to receiver. So these are the serial bus communication. And what is the meaning here? How devices send and receive data one bit at a time. If one bit is sending from transmitter, the other is receiving on the other hand. How many wires are used? In all these protocols, we are going to look how many wires are used, how devices send and receive data, how for the communication. It means the distance matters. Means whenever we are using, it means the distance wise they differ. The distance wise they differ, speed wise they differ. One more criteria to distinguish these standards: how much speeds they carry. Ultimately, we need the high speed, how fast the data travels. On these four criteria, we distinguish all the three recommended standards. In the first standard, in the brief, if there is one transmitter, other receiver, and the distance is very short, the less distance, it is approximately the distance of 15 meter and the speed is up to 1 Mbps. So distance wise, communication distance wise, speed wise, so this is the recommended standard, and it is useful for the smallest distances in the microcontroller. So RS232 is a serial communication standard for point to point, one-to-one communication. So this is the first recommended standard. So we are going to study the detail here. The first one is this is 422. I am just telling you, in the RS232 there is a distance wise. The distance wise it can cover the distance of up to 15 meter and the speed is very less. And just going to the this is our RS232. I told you that there is one sender, one receiver. There are three wire, one for transmitter, other for receiver, and one more wire for the ground. Maximum distance it can cover 15 meter, and the maximum speed it can 20 Mbps to 1 Mbps. Voltage wise, this is a single ended, noise protection is very low. Means in the first standard there is a one of the major drawback is the noise problem is there, and noise, and it can cover full duplex because the devices, there is only one device at the sender and the other device at the receiver. It means both can communicate. Means the sender can send its data to the receiver, and on the other the receiver can send its data to the transmitter. So this is the first. Once again I am going to back to the 422. This is 422. This is the, in the first what we are getting, the speed wise, distance wise, it is not good. So it is the upper version of the first one, one to many communication. In the first one there is one transmitter, one receiver. But in this there are 10 transmitter, one transmitter and 10 receivers. At one time, one transmitter can connect its data to 10 receiver. In the earlier one, there is the limitation 1 to 1, but it is 1 to 10 receiver. 4 wire. Earlier there were 3 wires, transmitter, receiver and ground. Now it has the 4 wire. 2 wire for transmitter plus minus and 2 for receiver, receiver plus, receiver minus. And there is the voltage level. What is the need to the voltage level? Plus 2 volt to minus 2 volt. Just to, in the first one we have seen that there is the problem of the noise problem is there. Now it can be clear by using this differential pair. It can minimize the noise level. And the distance wise, earlier we have seen the distance is up to 15 meter, but it can cover a distance of 1200 meters. And what is the speed? Earlier the speed was 1 Mbps, maximum 1 Mbps, but here it has the speed of the 10 Mbps, depend on the distance. Whenever we are increasing the distance, the speed automatically decreases. Or in the first one, there is the full duplex because one transmitter is connecting to the one receiver. It means the full duplex is possible there, but as whenever we are increasing we can increase the devices up to 10. If the devices are less, to full duplex is possible there. But whenever we are increasing the devices, to full duplex sometimes difficult to handle. So in that condition, we can connect it in the half duplex fashion. So both fashions, half duplex or full duplex, both are possible here. Where it is used, what is the benefit? Long distance support. Earlier the support is up to the 15 meter, it can discover a distance of 1200 to 1500 meter, less affected by noise. The first one has the noise level more in the 232. In the second, we have decreased it by using the differential pair. Higher data speed, these are the positive in the second recommended standard, and it is used in the industrial sensor, instruments, communication. It can communicate in the noisy environment, and it is applicable in the CNC machines, PLC machines. It is appropriate there, and there are cons, negative part is also there. Only one device can send data at one time because there is one sender and many receiver, but communication at one time is one send to one receiver. Needs more wire than RS232. In the RS232, there were only 3 wire. In the second one, there are 4 wires. So these are the cons that we are looking in the RS422 standard. The 485. In the first one, again we are comparing. The first one we have seen 1 to 1. Second one 1 to 10. In the third one, it can connect up to 32 devices. At one time, we can connect with the 32 devices. It can support the number of devices. It can support to more number of devices. So RS485 is the most powerful and the flexible serial communication standard. It allows multiple devices to send and receive data using 2 wires. So first one, number of devices, 32 devices, wire use 2 wires A and B, differential pair. Voltage level differential plus 1.5 to minus 1.5. It can control the noise level. It reduces the noise level. Maximum distance, if we compare this term, so I think this is almost to the equal to the second one. The second, but the difference is again there. That can support up to 10 devices, but it can support up to 32 devices. And the maximum speed up to 10 Mbps. It means if we are comparing the speed wise, first one is maximum 1 Mbps, second one is up to 10 Mbps, and third one is also 10. But I think the difference is here. At one time, one sender can connect with the 32 devices. That is the plus point here. Okay. If we are looking to the last part, at one time can one device talk to 32 devices? No. Full duplex is not possible. Half duplex cannot send and receive together because of the complexity. If you are going to the con part, so there is a complexity part is also there. Okay. So where to use industrial control system, Modbus, RTU protocol, building automation, temperature lights, smart meters, factory equipments. So this is the positive aspect. Many devices on same bus. Many devices means there are 32 devices, and all those 32 devices can connect on the same bus. Long distance plus high speed, comparatively it is equal, but 1200 meter is more than 15 meter as compared to the first one. High speed, very stable, good for industry. In the industrial purpose, for the industrial purpose, this is very good, but there are only one device can send at a time. Now, not all the 32 devices can communicate to each other. Needs software to control who sends. Basically, there are number of devices we are increasing. It means there must be the control system. There must be a system like the daisy chain system. It means we can distinguish between which receiver talk to the sender, the second receiver, third receiver, last receiver. So which one is the communication? It depends on the priority wise, which has the high priority to talk. So there is the daisy chain and other methods and other softwares to control who sends. Slightly complex setup. Whenever we are connecting 32 devices, the system may be complex. The system may be complex. So this is the short summary. As we have seen, the RS232 devices supported one sender, one receiver, one send, many receivers. Many means 10 receivers. Many sender, many receivers. Okay, up to 32. Wire, transmitter, receiver, ground, 4 wire, transmitter plus, transmitter minus, receiver plus, receiver minus, 2 wire A and B. Maximum distance 15 meter, 1200 meter. These two parameters are almost same. Speed up to 20 kbs to 1 mbps. Here it is up to 10 mbps, up to 10 mbps. This is almost same. Distance and speed wise, the second and third one is the same. Voltage level, single-ended, differential. This is single-ended. That's why the noise level is more in the first one as compared to the second level and the third. Noise protection is low. Noise protection is medium and high. But if we compare, these are almost equal. Duplex mode, full duplex, and this due to the complexity, it can go to the half duplex. So this is the differences between the three standards: RS232, 422, and 485. Ultimately, the moral of the story is how the devices can connect each other, how they are sending their data from the transmitter to the receiver. At one time, one transmitter can connect to one receiver in the first one. In the second one, one transmitter connect to the number of more devices. In the third one, the more devices up to the 32 devices. It means the number of devices are increasing one by one. And the way it means if the number of devices are more, number of devices are connecting, it means the data sharing is more. So that is the advantage in the RS422 and 485. In the real life analogy, if we are looking, RS232 means one sender, one receiver. Means two persons are only there, two people talking on the phone, one to one. So RS232 is the resemblance of the when two persons are talking to each other. If we are looking to the RS422, one teacher giving note to 10 students, the number of students are increasing. Here it is one person and at the receiving end, here is the 10 students. In the RS485, one group discussion, but one talk at a time. Senders and receivers, both are increasing in the third one, RS485. What is a controller area network? In this, if you are looking, this is first of all this invented by the Bosch in 1980. In this, how the mechanical devices like the engine, how they are talking to each other. One example, if when we press the clutch, it means the relation with the engine to change the gear. The first, it means the engine devices are also talking to each other. Now in this 2D era, we can connect one car with the ECU, electronic control unit. How we can identify the faults, where is the fault. It means the devices are also talking. So this is a communication system that allow multiple electronic devices called nodes to talk to each other without needing a central computer. It means all those devices, one node to the other node, they are communicating each other. It was originally developed by the Bosch in 1980 for vehicles like car, truck and buses, but now it is also used in the industries, robot and the medical devices. Full name controller area network. Type multi-master and message base. Multi-master. Communication, serial communication, one bit at a time. Number of devices up to 64 or more nodes. At one time, number of devices, 64 devices can be connected. Wire use, two wire. Can underscore high is one wire. Can underscore low is the second wire. Distance support. It can distance up to 40 meter at a high speed. As I told you, whenever we are increasing the distance, the automatically the speed decreases. It means up to 40 meters. It is at the high speed. High speed is how much? 1 Mbps. Up to 1 kilometer, if we are increasing 40 meter to 1 kilometer, so it means the 1 Mbps automatically decreasing. It can come in the kbps. Speed and error detection, yes, with built-in error checking. There is the error checking system and topology, bus topology, all devices connected on the same two-wire bus. All the devices, how many devices are connecting here? 64 devices, all those devices are connecting on the same bus. Okay. All devices connecting to the same two wire, any node can send data at any time. Multi-master. Messages are not sent to a specific device, instead each message has an ID. So there are the four distinguished way how the devices are connecting to each other. ID identifier tells what kind of data it is. Example, engine speed. I already told you that this is for the trucks, cars, and how they are communicating each other, how the engine parts are communicating each other. Data. Actual information. What is the actual information going from the transmitter to the receiver? That is 0 to 8 bytes. Error checking code. There is a option here. It can check the error, but whenever there is an error, there is a error checking code is there to identify where is the fault. Acknowledgement from receiving. Whenever any device from the transmitter send its data to the receiver, there is the acknowledgement. Yes, data is received on the other end. So this is very important. If two devices try to send at the same time, the one with the higher priority ID continues the other bits. This happens whenever two devices try to connect to the one transmitter, but which one is going to connect, which is the high priority than the other. That is main point here. So if the ID matches from the transmitter to the receiver, then it is the possible communication between the transmitter devices read the message. If the ID matches what they are interested in, that is most important here. Where it is used: automobiles, connecting engine, airbags, ABS sensors. ABS is anti-lock braking system, electric vehicles like Tesla for battery monitoring, industrial machines like robot PLC, medical equipments like the patient monitor, home automation, smart devices. Advantages: only two wires need for the multiple devices. It is the fast and reliable, work even in the noisy environment, automatically handles massive collisions because there is an error checking code is there. Error checking protection is there, saving wires cost in vehicles. Disadvantage: not suitable for very long distance, limited up to 1 kilometer. Limited data per message, only 8 bytes in a standard can. Slower than the Ethernet or USB, and needs CAN controller and driver. What is SPI? It's a synchronous communication interface. It is a communication system that allows one main device master to talk with one or more other devices. It means the four options are there. How the one transmitter is going to connect with the other slave. The master, which is the transmitter, the slave on other side is the device that is using to connect. If one master is out, slave, it means master is talking to the slave. This is the wire MOSI. Master out, slave in. Master send data to slave. The second one, MISO. It means the slave is sending back data to the master. Master in, slave out. Slave send data to the master. SE. This is a serial clock signal from the masters. Whenever they are going to connect, there is a clock pulse is there, and this option is the slave select and the chip select for the when two devices want to communicate to each other. This is the slave select or chip select option used to choose which slave to talk to. Which slave talk to which master, that is the chip select or the slave select option is there. Master sets a clock signal. Master selects the clock using the SS pin. Data is sent from the master to slave via MOSI. At the same